Welcome to the lesson on lean robotics. Upon completion of this lesson, learners will be able to describe the concept of lean robotics and explain the core cycle of robotics implementation, including its three phases. Learners will also be able to describe the four lean manufacturing principles of robotics. Let us start by defining lean robotics. Lean robotics is a systematic approach to robot deployment that applies lean manufacturing principles to robotics. It focuses on eliminating waste and optimizing processes. This methodology emphasizes quick, minimal, viable deployments that evolve through refinement rather than pursuing perfect solutions from the start. Lean robotics streamlines robot integration and standardizes deployment procedures. It maintains flexibility to adapt to changing production needs. In lean robotics, the core cycle refers to the iterative process used to systematically deploy and optimize robotic automation in manufacturing environments. The cycle consists of three interconnected phases that create a continuous improvement loop. The design phase begins with planning the robotic cell layout. Engineers select appropriate components based on application requirements. Teams define clear workflows that optimize production efficiency. All decisions are made with consideration for future scalability. Moving into the integrate phase, teams focus on building and connecting the physical system. Robot programming is implemented according to defined workflows. Critical safety measures are integrated into the system during this phase. Finally, in the operate phase, robotic cells are put into actual production. This is also the stage where performance is continuously monitored through key performance indicators, and teams identify opportunities for process improvement. Feedback from operations are considered for future design modifications. What makes this cycle particularly effective in lean robotics is its continuous nature. Insights gained during operation feed directly back into new design improvements, creating an ongoing process of optimization that aligns with lean principles of minimizing waste and maximizing value. Let us now look at lean manufacturing principles that guide companies through the entire robotic cell deployment cycle from design to operations. The four principles that we will discuss in this lesson are people before robots, focus on robotic cells output, minimize waste, and leverage your skills. Let's discuss them in more detail. The first principle in lean robotics is people before robots. This principle emphasizes that successful robotic automation begins with a focus on the human workforce. Organizations must prioritize worker safety and ergonomics when designing robotic cells to ensure a secure working environment. Before deployment, comprehensive training is provided to operators and maintenance staff to build the necessary skills and confidence. Team members are actively involved in the automation planning process, leveraging their experience and insights. Rather than pursuing full replacement, companies should consider opportunities for human-robot collaboration, recognizing that automation works best when it enhances human capabilities rather than replacing them entirely. The second principle is to focus on the robotic cell's output. This principle emphasizes that successful automation must be driven by clear performance objectives. Before implementation, organizations need to define specific production goals and key performance indicators, abbreviated as KPIs, that align with business needs. The focus remains on measuring cycle times and optimizing processes to achieve consistent throughput. Quality metrics and defect rates are continuously monitored to ensure the automated system maintains high production standards. The robotic cells are designed with maximum uptime and reliability in mind, ensuring that the automation investment delivers sustainable performance improvements. The third principle is to minimize waste. This principle focuses on eliminating inefficiencies throughout the robotic cell deployment process. Organizations must eliminate unnecessary movements and processes in the cell layout, ensuring every action adds value. Material flow and component positioning are optimized to reduce handling time and improve efficiency. The robotic programming is streamlined to include only essential functions, avoiding unnecessary complexity that could lead to maintenance issues. The design should include planning for quick changeovers and minimal downtime to ensure the robotic cell maintains optimal productivity while reducing time and resource waste. The final principle is to leverage your skills. This principle emphasizes the importance of building upon existing organizational knowledge and capabilities. Teams should build on their current manufacturing experience and knowledge when implementing robotic automation. Best practices and lessons learned from each deployment are carefully documented, creating a valuable knowledge base for future projects. Standardized procedures are created that can be replicated across different robot implementations, increasing the consistency. Rather than relying solely on external support, organizations should focus on developing internal expertise and empowering their teams to maintain and optimize robotic systems independently. In summary, Lean Robotics implements a streamlined three-step robotic cell deployment process of design, integrate, and operate. These steps form the core cycle, representing an iterative optimization where each phase informs improvements in others to maximize productivity and efficiency and reduce waste. The entire process is guided by four core principles: prioritizing people, focusing on cell outputs, minimizing waste, and leveraging existing skills. Thank you.